Good morning, everyone. Welcome to the fourth session of the AC400. So today we are going to cover two modules and a half. Actually, we will continue talking about analyzers. Remember that yesterday we finished talking about how we can integrate tasks that allow us to analyze our code in order to identify vulnerabilities, in order to give us insights about the code that we are providing. So we will continue talking about this. Then we are going to move into dependency management strategies. Actually, we will continue talking about Azure artifacts, and we are going to finish talking about monitoring our applications, how to get feedback from our customers as well as from the team in order to react to that feedback as soon as possible. All right, so let's continue with the static analyzers. So we have Sonar Cloud. Sonar Cloud again can be integrated with your pipeline in order to analyze your static code. They will give us insights such as refactor your code, maybe a warning, maybe a class a lot of classes that were detected as public, but they are not using anymore. So again, it will give us insights or give us recommendations in order to improve the quality of our code. Actually, Sonar Cloud joined investments with Microsoft, and it already supports a wide range of programming languages. Actually, well, the cloud version is known as Sonar Cloud, but you can have an on-prem version which is known as SonarQube. So we also have we can also integrate CodeQL with GitHub, and well, it treats the code like queryable data and standards or custom query analysis queries. What else regarding the security? We also have an OWASP test, so we can integrate an OWASP secure coding practices such as OWASP stands for Open Web Application Security Project. It's a global charitable organization focused on improving the security of software, and it regularly publishes a set of secure coding practices. Again, there are different tasks that can be integrated within our pipeline and can be used, for example, for penetration testing, or the testing can be active or passive, or conduct a quick baseline scan to identify vulnerabilities. So again, you can execute this maybe at a specific time of the day, or maybe during your pipeline. And what this is going to provide you, this will give you a report. So it always provides a report with results and bugs, and use a holistic and layered approach to security. So there are different tools, as I mentioned before. So we already talked about Sonar Cloud, Sonar Vault, OWASP, and Depend, among others. So all of these tools, many tools can be integrated within Azure DevOps, that is used for checking security policy during builds. So in this case, there is another discussion slide. Which tools have you ever used? Other thing, of course, this will depend on your specific application, but you can also integrate, or you can also create Azure policies for compliance perspective. So in this case, let's say that during your infrastructure as code, you're trying to create a virtual machine with a specific size. Maybe we are having some restrictions in the specific regions with a specific size by compliances due to something with our internal team. So again, we can create a policy that prevents the creation of those specific resources. As I mentioned yesterday, so when we talk about security, there are going to be multiple layers. So, for example, when we talk about we definitely have to protect the identities and assets. For example, we have to integrate the authentication and authorization. It's a good practice to enable the multi-factor authentication. Use the Use the release pipeline. You can also grant permissions using role-based access control. But at the end, we can also integrate the dynamic scanning. Different approaches when we talk about the security of the pipeline. So to improve security in general, you can use Azure Resource Manager templates or other code-based configurations, and infrastructure as code best practices, such as only making changes in templates, thereby by making them traceable and repeatable. What else? You can also enable the Microsoft Defender for Cloud. Basically, it's something that you enable, and this will give you recommendations based on the security of your infrastructure. It uses Azure Machine Learning in order to identify, in order to detect abnormal events or unusual activity. It gives you recommendations based such as in the network security groups, in the amount of traffic, in the logs that are created, and it is available in two pricing tiers. So one tier is going to be, both tiers has to be enabled, and there are different costs associated based on the different tiers that exist. What are the scenarios? For example, you can use Security Center for an incident response. This will let you detect and verify a high security alert was raised, access, obtain information about the alert, and diagnose, follow the remediation steps. What else? We also have to say the scenario number 2. You can use Azure Security Center recommendations to enhance the security, security policy recommendations. So we can monitor, or we can see, or we can get reports if we are being compliant with a specific policy. So let's continue talking about the policy. So Azure Policy is a service that you use to create, assign, and manage policies. So in this case, we will create a kind of rules in a JSON format that prevents the creation or the deletion or some operations within our Azure environment. Let's say you can create an Azure policy that prevents the creation of a virtual machine in a specific region, or the creation of a virtual machine in with a specific size. So you can manipulate, or you can guarantee by using the Azure policy. So if we have a pipeline that is creating infrastructure as code, but we want to make sure that we are compliant with our specific rules, again, that Azure policy will be evaluated, and if it's not compliant, it will prevent the creation or the execution of that specific task inside the pipeline. So it can be integrated with an Azure DevOps by applying any continuous integration and continuous deployment pipeline policies. What else? So how the policy will be created with a JSON definition. So we need to specify here the policy rule. So in this case, there is the display name. We have the description. This policy enables you to restrict the location your organization can specify when deploying resources. There is a policy rule, and then which effect is going to have. So we can assign policies using the Azure portal, Azure CLI, or PowerShell. And you can use it for remediation for not compliant resources. This is the screenshot. The screenshot is a section of a policy file defining a load allocation. So very important to mention that every policy definition has conditions under which it is enforced, and an accompanying effect that takes place if the conditions are met. So the process of applying a policy to your resources consists of the following steps. You need to create a policy definition, assign a definition to a scope of resources, and view policy evaluation results. What else? We also have initiative definition. So initiative definition is a set of policy definitions And this will help you track your compliance state for a larger goal, and it's assigned to a specific scope and reduce the needs for individual scope assignments. So initial example, create an initial named enable monitoring in Microsoft Defender for Cloud. So this will provide the following policies: monitor unencrypted SQL database policy definition, monitor UOS vulnerabilities policy definition, and monitor missing endpoints protection policy definition. So basically, is how we can guarantee or how we can prevent specific operations are being executed within our Azure environment. For example, we also have the resource logs. So this is a rule that can be created at the resource group level. And with this, we are going to prevent that a resource group is not deleted or cannot be modified. Therefore, this will apply to all the resources that belongs to that specific resource group. Actually, let's make a quick demo here. If I open my Azure portal, let me take a look to a resource group that I already have. If I go here to resource group, I will choose this one. So this one that I created yesterday with virtual machines. So this is the resource group. If I scroll down, there is an option that is going to be logs. So I can create a log by providing a name, no deletion, right? And that is going to be just for delete. I mean, it can be modified, but it will prevent the deletion of this resource group. If I try to delete this resource group now, or any resource that I have inside this resource group, I won't be able to do this because there is a log there and I won't be able to delete it. The only way to delete this resource group is by deleting that resource log. We can also change it to read only, and it will prevent the modification or the update of for that specific resource group. What else? We also have Azure Blueprints, which allows, or Azure Blueprints is also useful in Azure DevOps scenarios where blueprints are associated with a specific build artifacts and release pipelines and can be tracked more rigorously. Well, it is important to mention that at this moment, Azure Blueprints is in preview and has not yet been released publicly. But it is like having a template, but there are slightly differences. So how do Azure Blueprint policies differ from templates? So the blueprints in Azure Blueprints are different from Azure Resource Manager templates. So when Azure Resource Manager templates deploy resources, they have no active relationship with the deployed resources. By contrast, with Azure Blueprints, deployment is tied to an Azure Blueprints package. So basically, we're going to ensure that deployment meets an organization standard, patterns, and requirements. That is a declarative way to orchestrate deployment for various resource templates and other artifacts. All right. And okay, so with this, we already finished this module. So let me recap what we covered on this module. Basically, we start talking about the security. So remember that security is everyone's responsibility, and we are going to have multiple layers. So you can monitor your infrastructure, your application, the security in the pipeline, who is going to have access. So based on this, so there is a set of practices known as DevSecOps, which is a set of practices designed to integrate DevOps and security. For example, while the pipeline, we can introduce source scanner, and these source scanners are going to give us reports once the pipeline has finished, such as the vulnerabilities, the severity. Very important to keep in mind that this can give you false positives. So one example of this is White Source Vault. Another example is SonarCloud. Give us recommendation based on design patterns in the code and code smells, such as warnings, code that is not being used, among others. We also have OWASP, so the report provides a report with results and bugs. And also, if you want to prevent the creation or if you want to meet compliance goals, we can integrate policies that prevents certain operations being executed inside our Azure environment. With this, we are done with this specific module. Remember that if you have any question, feel free to post it into the chat. There is a team that is answering to all of your questions. All right, so let's continue with the next module, which is about the design and implement a dependency management strategy. Let me start by opening the DevOps portal. Remember that for each organization, we will have the different projects. We will have the same options, such as we have the dashboards, we have boards, repos, pipelines, test plans, and artifacts. Let me focus on this part, in artifacts. We already talked that from the continuous integration stage, the product or the part that is going to be created is known as artifact. So the result that comes from the result that comes from the continuous integration is known as an artifact. All right, this can be a compiled application, a zip file, or a Docker image. Guess what? When we talk about artifacts here, this service can be seen as another approach. This can be seen as a way where we can push our custom libraries, all right? Or we can also centralize custom and public libraries. And that's it, guys. Actually, normally for different programming languages, there are common packages. For example, with C#, we have NuGet. With Node or with JavaScript, we have Node modules. With Python, we have pip. With Java, we have Maven. And actually, by default, let me open my Visual Studio just to show you that by default, when we are using Visual Studio Code, if we are trying to download a file or a package, let me show you this. NuGet Package Manager settings. So if I click here on the NuGet Package Manager in the package sources, so by default, these are the packages where Visual Studio is going to be looking for download our codes, for download external packages. So if you're trying to install a package in your application, the first thing that Visual Studio is going to do is like look where this package is coming from. So this is the different sources where this is going to be looking for. However, if we create our custom libraries, we have different options. For example, let's say that we have created a C# library. We can upload it to NuGet. However, the trade-off here is that it's public. So if we want to work with our custom libraries, with our custom packages, this is when Azure Artifact comes into play. The first thing that you need to create is something known as a feed. So inside the feed, you can specify the name, the visibility. I mean, which users are going to have access to that specific feed. And one of the options that we have inside a feed is the upstream. So what the upstream is, basically, we are going to allow to include packages from public sources. So in this case, instead of looking to multiple sources, we can centralize a single source for all the packages that we are looking for. Basically, that is Azure Artifacts. Inside the Azure Artifacts, remember that we have the feeds, and then we can provide different public sources. Actually, let me create a new feed. My testing feed. So I can specify which people is going to have access. if I include upstream sources or not. Let me create it. There we go. So here I will be able to switch between different feeds, and the way that I will be able to connect is going to depend based on the type of packages or based on the IDE that you are using. For example, in Visual Studio, I can just grab this source, and then this source can be integrated in the window that I showed you before. Here in Tools, NuGet Package Manager, NuGet Package Manager Settings, in the package sources, I can add a new source, and here I can provide the URL that was provided to my feed. But you might be wondering, so here is for consume, but how can I do, or what can I do in order to push my custom code? So in order to push my custom code, there is a series of packages that must be downloaded. So first of all, you need to download Visual Studio in this case. There is a series of steps that you need to follow. And actually, in your lab, you will execute a lab that will let you push your custom libraries. And then from that custom library, you will consume it. So actually, you are going to have two projects. One project that is going to consume the package, and another project that is going to create the package. Now, this is from a big perspective. Now, let's continue with the topics. So, what is dependency management? First of all, modern software is complex. So definitely we need to modularize, we need to create different classes, different functions with different functionality. And component-based development is common. Not all the software is written by a single team. As we discussed yesterday, maybe in any way, sorry, we are consuming open source software, open source packages. So there we are going to have different dependencies on components created by other teams or persons. So what is the standards? What is the elements of our dependency management strategy? First of all, we need to create a standard. Then we need to give a package format and sources, and we need to create different versions. One thing that is very important to mention is that every time a new package is uploaded, a new version will be created. Keep in mind that each package is immutable, all right? So we cannot update a package. We cannot update an existing package. The only thing that I can do is to create a new version. So by creating a new version, it's like updating, but I cannot modify an existing version. So you should find the components and source code that can have independent deployment, release, versions, and you should consider the frequency that you are going to change this. Changes should be unrelated to other parts of systems. You can package exist by itself, and the package should add value for others. So what is source componentization? The split out the components. It can be related to projects in different solutions. And package componentization is composing your solution to use packages. So how we can decompose our system? We can draw a dependency graph, such as the top level dependencies and the down level dependencies. So you can specify through the approach. You can draw a dependency graph and group components in sets of related components. And you can fuse pattern check-ins across sets. Ideally, a single team is responsible, and you can share release cadence for a single set. Actually, we can integrate this with the source scanners we covered in the previous module. You can score your code base for dependencies. For example, you can identify duplicated code, high cohesion and low coupling, individual life cycle, stable parts, independent code, and components. So what is package management? So again, there are common sources that give us or that provides common packages. Normally, this will depend on the programming languages. For example, we have Nugget for C#, Node for JavaScript, Python, Docker. A package is a formalized way of creating a distributable unit of software artifacts that can be consumed from another software solution. Inside Azure DevOps, we have the package feeds. With package feeds, will let me centralize storage of package artifacts, and these artifacts can be public or privately available. Remember that when your feed is created, you can specify which users or which entities are going to have access to those specific packages. Offer secure access for private feeds. We can have multiple versions, and it is totally managed. There are different types of packages, all right, and private, also known as package repositories or package registries. I would say that Azure Container Registry or Docker Hub is a package registry where we can store our Docker images, and the package repositories might be such as Nuget.org, npm.js, PyPy, so to store packages related with code. And from our IDE, or from when we are developing our application, this is where we are going to be able to specify where to get those dependencies. And not only for our application. Remember that every pipeline requires infrastructure, requires the agent where the artifact, the first result is going to be built. So on that agent, keep in mind or remember that the packages should exist. All right, so should exist, and that's it. So explore the feed, the package feed manager. So we have the managed feeds. We can search and list packages from all the feeds. We can consume the packages from our IDE. So you can maintain a local installation cache. You can also publish your packages. So there are common public package sources such as NuGet, npm, Maven, Docker Hub, and Python package index. So how we can consume the package? First of all, you need to identify a required dependency in your code base. You need to find a component that satisfies the requirements for the project. You can search the package source for a package offering a current version of the component. You should install the package into the code base and development machine and create the software implementation that uses the new component. So basically, is that once you have identified this, you need to, maybe if you're trying to use a specific package that doesn't exist in your local computer, you can go there and you can open the package manager. So here in this way, the console, and we can install, we can specify which extensions are going to be installed, which packages are going to be installed. The package manager. There we go. So we can specify which packages are going to be installed. So in order to store our private packages, we have Azure Artifacts. This let us create private and public packages feeds for package types such as Nugget, npm, Maven, Universal, or Python. There are different sources that we can have in our packages. So how to publish the package from the Azure DevOps portals? These are centralized, and you will specify a name, the visibility, and which people is going to have access. And remember that if we want to integrate public packages or public libraries, we need to enable the upstream option. Now, other thing that is important, remember, because one of the most important aspects here is, okay, so how I will publish a package. So in order to publish a package, there is a set of instructions that we have to follow. All of this is going to be covered in your labs. Remember that in your labs, you will publish a package. At the same time, you will consume that specific package in another application. Remember, guys, that there are, feel free to post any question into the Q&A chat. There's a team that is answering to all of your questions. So let's continue talking about updating the packages. So an artifact is a deployable component of your application. So Azure Pipelines can work with a wide variety of artifact sources and repositories, and each release can specify which version of the artifacts are required. Azure Artifacts can eliminate the need to manage file shares or to host private package servers. And Azure Artifacts provides a universal artifact management for Maven, NPM, and NuGet. So based on the type of package that you are going to push, there are different documentations, such as how to deploy it based on a NuGet, based on JavaScript, based on Maven, based on Python. So regarding the secure access to package feeds, so feeds must be secure. We have private feeds that not allow access by unauthorized users for publishing, and there is a restricted access for consumption. So whenever a package feed and its packages should only be consumed by a certain audience, it is required to restrict access to it. And only those allowed access will be able to consume the packages from the feed. So actually, we can also specify the permissions that each package is going to have. So with this, remember, based on the role that we have specified, the different permissions the user is going to have. We have reader, collaborator, contributor, owner. So actually, well, the reader can list and restore packages from the feed. The collaborator can save packages from upstream sources. The contributor can push and list packages in the feed. And the owner has all of the available permissions for a package feed. There are different types of permissions that we can specify. So roles have certain permissions, such as reader, only list and restore installed packages. Collaborator, list and restore and installed packages, save packages from upstream sources. Then we have the contributor, list, save, push, list, but the contributor doesn't have access to delete or edit the permissions. So this can be achieved just by the owner role. Based on the role that we have specified, there are different permissions that are going to be available. Sometimes we can also enable the authentication. So external package sources may require credentials. So in order to do this, we need to create a connection. What else? When we talk about versions, remember that each package must have a version that let us identify, that let us maintain. Well, maintain in the case of creating a new version. But remember, very important, actually, let me highlight this. Packages are immutable. So once published a package, it cannot be changed. We can just create a new version. So replacing or updating a package is not allowed, and any change requires a new version. Other thing that it is important to consider is that we need to specify a standard or a mechanism that allows to provide the different versions. So the version of the artifacts is a way to express version technically, whereas for package type. So normally this number is divided into 3 numbers or 2 sections: major, minor, and patch. So this will express the nature and risk of change. So the first numbers are nature of change, and the second part is the quality of change. What are the best practices for versioning? Have a document versioning strategy. You can adopt Semver 2.0 for your versioning scheme, and each repository should only reference one feed. And on package creation, automatically publish packages back to the feed. Well, this is from Azure DevOps. We can also integrate GitHub packages. So GitHub packages is a platform for hosting and managing packages. You can combine source code and packages in one place. You can integrate permissions, management, and billing. And you can integrate GitHub packages with GitHub APIs, GitHub Actions, and webhooks. For this, we have the container registries, RubyGems registries, NPM registry, Apache Maven registry, Gradle registry, and NuGet registry. So again, the process will be the same. So we can have a place where our packages are going to be centralized. And in order to push those packages, we need to follow specific documentation based on the type of package that we are going to update, that we are going to push. So again, based on your IDE, this is where you can install, or you can see, you can visualize the different packages that can be downloaded, that can be installed in your specific application. And sometimes you must be authenticated. You can install a package using any supported package client, such as in Visual Studio comes with this kind of client. In some packages, you must be authenticated, and you can install the package using the instructions for your package client. So you can also delete and restore a package, an entire private package or an entire public package. And well, with this, we're done with this specific module, which is about package dependencies. So remember that basically, we are using a service that let us centralize all the package and all the libraries that were created by ourselves, right? And we can consume it by our IDEs. So let me continue with the last module. Now let's talk about continuous feedback. So how we can get information or how we can get insights from our customers or from the team, because remember that we have to share the knowledge. So let's continue here. First of all, we need to implement tools to track usage and flow. Remember that the inner loop is about, we are going to have iterative cycles when we are going to code, we are going to build something, then we are going to test. Those features are going to be used by our customers. We will get some feedback, and we will continue coding, building, testing, coding, building, testing. So all of this to improve the quality or to give more valuable to our customers. But in order to make better decisions, definitely we need to monitor. Remember that we cannot improve something that cannot be measured. So in that case, so when we talk about continuous monitoring, we can monitor different aspects, such as the security. So how to protect the data in case of a disaster. I need to establish mechanism in order to have more availability in our applications. Or what else? Monitor. We can monitor the application, the infrastructure, the network monitoring. For example, we can monitor the infrastructure as well as how the users are interacting within our application, if they are using the new functionality that we added or not. What else? The compliance. What if the data cannot leave that specific country? Or what if the data must be encrypted with a specific rules or something that we have to consider? And also the configuration. So there are different aspects when we talk about monitoring. So for the infrastructure as well as the application, we have Azure Monitor. This can be integrated with different services within Azure. Each service is going to be generating metrics and logs, right? And we can integrate this, for example, with application insights, or we can visualize with dashboards. We can also respond by using auto scale rules in our services, or we can also create alerts. Alerts, remember that we can that can be created based on different criteria. Actually, let's make a quick demo here. So for this, let me select my virtual machine, one of the virtual machines. And if I scroll down, I can go here to the alerts. I can create an alert rule, and I need to specify the signal type. So based on the resource that I have selected, there are going to be different signal types. In this case, the CPU credits consumed, the CPU credits remaining, data discharged, disk read bytes, custom block search, so, or maybe the bandwidth. Let's select this here, so I can specify a criteria, the unit, if I exceed more than the 80%, or if I exceed more than a specific amount of money, I'm going to check every 1 minute. So there are different conditions, right? What else? I need to specify the action. So how I'm going to react when this alert is triggered. Maybe I want to send an SMS, I want to invoke a custom webhook, I want to invoke a function application or a logic app. So all of this is how we can react, or how we can respond to those alerts that are being triggered. So there are different ways that we can integrate these specific alerts in order to make better decisions. Actually, there is a language that allows us to query all the logs, which is known as custom query language. So custom query language is the language used to query log analytics, supports queries and control comments, and is supported within Azure Data Explorer and Azure Data Studio. So how we can, if we take a look to application insights, so we can monitor, for example, our infrastructure, or we can also monitor, it can be tightly integrated with app services or with applications. With this, we can monitor, let's say, the amount of exceptions, the 404 responses, the amount of traffic that we are having, and we can also integrate from the client side. From the client side with JavaScript, we can also see how the user is navigating through our website, if the user emit or triggered a specific events or not. So this can be done with application insights. Can be integrated within our application. Actually, let me show you how we can do this. Let me go to application insights. I already have this one. So for each application insight resource, an instrumentation key is going to be assigned. So based on this instrumentation key, app insights, let me type here JavaScript, just to show you for web pages. Well, here is for Node, but I just want to use a vanilla JavaScript. It has to be a vanilla JavaScript configuration. Well, here is the documentation, but actually there is a snippet, there's a code snippet that can be used without installing anything with npm, just by the JavaScript version that comes with the browser. That basically is a portion of code that you provide that is available in different packages such as .NET, such as Java, Node, JavaScript. And with this, we can create a telemetry client, and we can track different events. And those events are going to be received inside this specific portal. And we can also receive the failed request, the sample response time, the availability. We can create charts. We can see how the user is navigating the different sessions. This will give us information such as the browser version, the location, or different events that were triggered by the user. So the main idea is that we want to monitor in order to detect or diagnose. Based on this, we will be able to make decisions such as build, measure, or even learn. We can also create dashboards, such as the amount of requests that we're having, the amount of users, the security, so anti-malware assessments, system update assessments. Based on this information, we can make better decisions. So this can be tightly integrated with Azure Monitor. And we can also create dashboards within Power BI. I mean, all of the information can be integrated with Power BI. That's it. Or even you can create your custom application. But of course, what is the advantage of create your custom application is the flexibility and the metrics and log data. So you are more flexible, especially providing which information you want to receive or you want to get. However, the disadvantage is the significant engineering required. Now, when we are sharing knowledge with teams, remember, this is about the continuous feedback. The module name is about continuous feedback. So we can also get feedback from our internal team. So there is something known as organizational knowledge is acquired over time. So we need to create documentation, or we need to provide information about what's going on in all of the future. Relearning all lessons is wasteful and expensive. And organizational knowledge can easily be lost through staff turnover. So which knowledge sharing tools do you currently use? What do you or don't you like about the tools? Well, in my other jobs, I have already used Slack, for example, Microsoft Teams. Or remember that we can also create wikis for each specific project. Remember, the idea is to share the knowledge, or we already have the documentation that we are passing through the creation of that specific project, such as I don't know, a bug fix or something documentation with the pipeline. So we can specify how the pipeline works at the end. So something, I mean, in order to share the information with other users. Actually, within these wikis, we can also provide diagrams, so known as mermaid diagrams, which is like having blocks of the diagrams that can be used. So these diagrams can be written in Markdown and can contain file attachments. Actually, we can also include videos. What else? We can also explore rapid responses and environmental search in agile teams. Issues that slip through the cracks directly impact end users, and speedy resolution required, even if root the cause determined later. Large volume of infrastructure and application logs to search. Environmental search uses semantic processing, statistical models, and ML. Other thing that we can monitor directly in our application, guys, there are different browsers. There are different extensions that can be installed at the browser level. And with these extensions, we can um, we can track or we can record video of how we are interacting with our application. And with this, we are going to be able to store that information within the test plans. So within the test plans, we will be able to perform a series of tests that are going to be integrated or that are going to be executed within our application. And all that information is going to be stored inside the test plans. For example, if we record a video or if we create a bug that is going to be linked directly to a task inside the items within Azure ports. Other thing that we have to consider is that if we are monitoring an application from the client side, is that maybe the users doesn't want to enable it. Users might not be comfortable with the monitoring. So you need to monitor the tools and technologies such as synthetic monitoring, alert management, deployment automation, or even analytics. What else we need to examine when to get notification? Well, application insights automatically analyze the performance of your web application and can warn you about potential problems, such as I mentioned before, the amount of exceptions, maybe a 404, the amount of traffic that we are having. Based on this, we can create alerts. These alerts can emit or can trigger different actions. Actually, there's other tool known as the smart detection. With the smart detection, again, we can get information such as slow page load time, slow server response time, long dependency duration, or even degradation in server response time. And all of this to improve the performance. So once we have diagnosed something, so we can react or we can monitor those specific parts. So first, for example, we need to understand the server response time degradation. So we need to define a base, what is normal and what is abnormal, how many users are being affected by a downtime, the kind of operations. Based on this is how we can specify the criteria that is going to trigger the alert. And well, very important to mention, monitoring and alerting enables a system to tell us when it's broken or potentially what's about to break. Based on this, we can react. We can create alerts requesting immediate action that should be urgent, important, actionable, and real. Okay, so with this, we are done with all the modules, guys. So I will make a quick wrap up. Just to finish with these specific topics, there are going to be some labs. For example, remember that within Microsoft Teams, you can install an extension. Open Microsoft Teams here. You can install an extension that basically can give us or let us link different work items. So in this case, if I create a conversation, I can specify, hi, we need to fix this urgent. So automatically I can link to existing work items. There we go. Like that. So other lab related with these topics is that you are going to create an application, and that application is going to enable application insights, and the application insights we are going to monitor, such as how many alerts or how many exceptions were triggered or were raised. And actually, based on these alerts, we can also query these alerts from the release gates. There is another lab, guys. Remember that we will have different phases when we are deploying the application. So let me scroll down here. where it is, the release gates. So if I go to pipelines, to the releases, so we can have different operations that are going to be executed before and after each stage. And again, one of the operations we can execute this is to query the alerts. All right, so query the alerts. So in the case that an alert was triggered, and this process or this process is not going to continue, so we can prevent deploying this application to production. So something that was triggered by application insights and can be integrated with the past or pre-deployment conditions. What else are you going to do in your labs? In your labs, you're going to work with a project, and inside that project, a wiki is going to be created. All right. So let me wrap up all of the course, guys. So remember that DevOps is a set of techniques that allow us to speed up the process while delivering software, right? So this is going to involve agile methodologies, pipelines, having feedback from your users, monitored, automation, infrastructure as code, as others. Then, for example, these pipelines are going to be divided into two stages normally. We are going to have the continuous integration, and we are going to have the continuous delivery. Normally, the continuous integration is going to be triggered every time a code or every time there is a change in the version control system. That will be a process that will be fully integrated. Example of this might be compiling the code, executing unit tests, executing scanners, such as these scanners will give us insights or recommendations in the code, such as vulnerabilities or warnings or code that is not being used. Example of these scanners are White Source Vault, SonarQube, among others. Then once we finish the continuous integration, something is going to be created. That something is known as artifact. That artifact might be a deployable resource, maybe a Docker image, maybe a zip file. Then what the artifact is going to be passed to the releases. In the releases, we can integrate, and every time an artifact is available, we can trigger the release process. So the release process, maybe we're going to create the infrastructure. So remember that when we talk about infrastructure as code, we are going to have different options such as Bicep, ARM templates, Terraform, Chef, Puppet. And we also talk about how we can automate the configuration of that infrastructure, such as Ansible or Azure CLI or any other script, Chef or Puppet. So basically, imagine that you're going to deploy a zip application in a virtual machine. So you need to make sure that that virtual machine is supporting the server that has to be installed. Maybe that server can be installed by using PowerShell, decide state configuration, maybe by using Ansible. But the main idea is that we are automating the creation and the configuration of our infrastructure. What else? Inside the pipeline or inside the releases, we can have different stages. And these stages, we can have pre-deployment and post-deployment conditions. So with this, we will be able to perform evaluations, or we will be able to perform some operations before continue with that specific process. Other thing that is very important regarding the pipeline is that remember that each pipeline requires its own infrastructure. This is something known as agents. So by default, inside Azure DevOps, we are going to have the Microsoft hosted agents. Hosted agents. So this is going to provide us with a set of packages that with some agents that already comes with a predefined packages. So how to specify the agent? You have to make sure at least, so one good starting point is that you have to make sure that based on the artifact that you are going to create, the agent contains the packages that are required, the management tools. If any of these agents support the package that you need, In that case, you need to create something known as a self-hosted agent. So a self-hosted agent is when you provide your custom machine or your custom infrastructure to create your specific to run your specific to create your specific artifact. So this requires an entire process. So you need to go to your organization settings. Then if you go to agent pools, there is a pool already created. Then if you go to agents, when you click here on a new agent, there are different documentations based how to install that specific agent. And we also have the Azure artifacts. Within the Azure artifacts, we will be able to store my private packages, right? So with these private packages, then I will be able to store private packages. Then remember that I need to create something known as a feed. In the feed, I can establish which entities are going to have access to that specific feed. And if I want to integrate external or public packages, we also have the upstream source, the upstream option. With the upstream option, practically, we are specifying that we can receive public packages. And well, what else? Just to finish, we also have the repositories here in Azure DevOps. Remember that every time a pipeline is created, the first thing that we need to provide is where is the source code, or where the code is coming from. All right. So there are different labs, guys, such as creating pipelines, play with the repos, play with the release dates, pre-deployment and post-deployment conditions. And that's it, guys. So with this, I think that we are done for the seminar. Tomorrow we are going to have another session where we are going to give us more details about the exam. We are going to prepare a series of questions and answers. And I will stay here for a couple of minutes just to monitor in case that you have any question or anything I can help you with. Don't hesitate to drop us a question here into the Q&A chat. All right? Thank you so much, guys, and see you tomorrow.